Yeah, so hi everyone. So the purpose of this video is just to create a interview experience video about what questions I was asked and then how it all went and what type of roadmap you should follow for machine learning engineer role. So recently I gave an interview at eBay. So yeah, this was not an interview, it was the first round actually. But then I just want to tell you guys like what you should be focusing on if you're going for a machine learning engineer role. And the package was pretty decent, I'd say. It's like a very good industry standard, above 10 LPA, definitely. I'm still waiting for the results, so I'm not sure whether I qualified, I didn't qualify, but I'm really not sure. So yes, so let me just start with it. I'll just start with it. Yeah. So, what I was asked was the first question was around precision, recall, and these things. Like, for this particular scenario, what do you think should be the threshold of the precision for a particular task according to you? So, for this, there is no right or wrong answer. It totally depends on the person and his experiences and what he has coded, learned, saw in the industry and stuff. And then again, like, do you actually know how to calculate precision, recall, and these things given a table? So they also checked it. So I had to calculate for five tables actually. Like there were five tables and they had some scenarios. So according to them, which of the tables would actually give you that correct answer? Then the other thing which I was asked was ensemble techniques, like what are those? Bagging, bootstrapping, do you know these? Then differences, then what kind of replacement techniques they use to create their pool from the data, whether it's with replacement or without replacement. Then what type of learners are involved in this? Are they weak algorithms, strong algorithms, something like this? And then is validation always necessary for every weak algorithm which is trained? So stuff like these, like the basics only, but you have to go through. So I'll suggest like only Krishna sir's video is pretty good on that. So it will like really help you on these, like what are the core fundamentals or the techniques which you actually have to use in working in real life industries. And then about some linear data, non-linear data. If like the relation is linear, if like the relation is non-linear, then which machine learning model or method you'll use in order to tackle those. Then something around overfitting, what is overfitting, then bias, variance, their trade-off. So these things, and then let's say they will say for a particular scenario we want the bias to increase and the variance to decrease. Then what would you be doing? Like increasing the data, increasing the epoch, increasing the number of iterations, stuff like these, regularization, etc. Then there was one question around PCA versus LDA, which is like the principal component analysis and the linear discriminant analysis, if I'm not wrong. So it's mostly for dimensionality reduction. So let's say we have a very large data and we want to work something around it, but we are not very sure. So we want to extract good features from it so that with less amount of data also we could be able to predict the answers really well with high accuracy and precision and F1 score and stuff. So this is a these techniques are used for those stuff. So like when to use LDA, when to use PCA, which one is better based on which scenario. Then if you're considering variance, whether you'll go for PCA or for LDA. So these are the questions which were actually asked. Then if the data has a lot of nonlinear relationships, then which of these two would you be using it? If the data is a lot multicollinear among itself, so which of the methods among these? Then the other question is around naive Bayes. So yeah, so I have a sheet actually which I'm looking into and just telling you guys as I remembered and I wrote it down. So naive Bayes versus KNN, when to use, which to use, which is more complex to calculate, which is good if the data is less or more. Then which would be the industry standard for a particular process, let's say for a car price prediction or let's say for a loan prediction, something like this. Then which is more accurate regardless of the k parameter. Then what do you mean by the non-parametric nature of the naive Bayes? Then the zero frequency problem in naive Bayes, how do you tackle that? Then these things, and yeah, mostly these things guys. And yeah, neural networks as well. And they actually literally gave me a neural network and to ask me to calculate it. so that to also check like whether I actually know the ground level calculations or not, and what activation functions do you know, how to use these, what to use, when to use, then yeah, stuff like these. Then also they made me like just write the expression of uh, sigmoid function like np.exp, something like that, just to show that yes, I know the basics fundamentals actually. And then from the coding part, you should definitely check out what from my experience what I know. Still I'm also learning. Like you should at least know the raw code as in the what do we call it here, scratch implementation. So you should go through the linear regression, logistic regression minimum for sure for entry level. And if you are a little senior, then maybe the decision trees, the decision tree classifiers, then maybe little bit of svm also knowledge is very good. Then what was that? Yeah, bagging also you should know what is it, how is it done. Then the coding implementations, they won't tell you to write it from scratch. Yes, if it's very basic like logistic regressions or linear regression, then they may tell you that like using the numpy libraries or stuff you have to do it. Otherwise, if like it's a pretty big one, let's say for decision trees or let's say for a random forest, then they will give you like the whole code, and there'll be like snippets missing, like which would mostly be the logic and the formula which is actually used for the naive base, like the entropy formula. So those things you'll have to code it by yourself, and like you also have to know like how those things are used from the numpy side, since numpy is actually way faster than arrays. In machine learning, actually most of the work is on the numpy stuff and pytorch, these things. uh, yes, I guess mostly that was all. And from the DSA there was like this string question, like string manipulation, I will say. And then the array, like you should go through this let's say for the find the longest substring, then given a particular string, compare it with the other string and tell that how many times these are occurring in the larger string, something like these. So yeah, this was like the overall experience. It was pretty decent. Yep, let's see, waiting for the response from their side. Yeah, and this was a like old video, but I'm actually posting it today, so yep.